Assalamualaikum warahmatullahi wabarakatuh. To meet the Yusrina. My name is Amira Syazwani Binti Aminudin. So today I would like to present the simulation for assignment Power Electronics. So first of all, this is our circuit in the simulation. So the question asks to simulate the three-phase full bridge inverter. So in this circuit, we use 6 IGBT here, 1, 2, 3, 4, 5, and 6 because for three-phase full bridge. And then we use DC supply, so we set here 240 volt. And then for RL load, we set here for 30 ohm and 50 millihenry. And then for reference signal, amplitude reference signal, we set as 234 volt because the amplitude of carrier signal is 130% of voltage supply. So we got here 234 volt. Next, why we use DC supply here? As we know, the inverter function is to convert the DC signal into AC signal. So in this simulation, we want to convert into AC signal by using SPWM technique. SPWM is stand for sinusoidal pulse width modulation. So we have 3 sinusoidal reference here, and comparing with carrier wave, we use 1 triangular wave and 3 comparator.
Bismillahirrahmanirrahim. Assalamualaikum and a very good day. My name is Muhammad Nusair bin Muhammad Roslan, and today I will be showing the result of a simulation done to a three-phase full bridge inverter with SPWM control. Question A asks for the waveform of our reference blue signal and our carrier signal, while question B asks for our PWM number 1, and question C asks for the opposite PWM1, which is PWM2. So let us simulate the circuit. The first waveform shows that our reference blue signal, the sinusoidal shape, and our carrier signal, the triangular shape signal, overlap each other to produce our first PWM signal. The PWM signal is operate during the positive half cycle of the inverter, which is when the reference signal is greater than the carrier signal, which produces an output of 1, while when the carrier signal is greater than our reference signal, it will produce an output of 0. PWM2, however, is the opposite of PWM1. PWM2 operates during the negative half cycle of the inverter, and thus the waveform is the opposite of PWM1. So that's all from me. Thank you.
So next, I will show about question D. So basically, question D asks to show the phase blue voltage. Before we run the simulation, we have to set the simulation control. So the print time is 4 seconds and the total time is 4.06 seconds. So the total time is 0.06 seconds. That means that this simulation has 3 cycles because one cycle is 0.02 seconds. When we already set here, so we can run the simulation. So because we want to see the VB, so we choose VB here and then add. So here we go. So we want to see from 4 seconds to 4.06 seconds. So we reduce the, so this is the phase blue voltage from 4 seconds to 4.06 seconds. So as shown, the result of BMW switching will produce the output waveform which contains different Sorry, which contains many passes with different ways. That's all for me. Thank you.
Assalamualaikum. My name is Amira Syazwani. So, to measure IR current, we just connected a enter at this point to this point of red line. So, if we run this simulation, we just get the output current like this. As shown here, the output current, if similar to the output voltage of red phase, but different in amplitude and wave shape. Since the current flow through 30 ohms and 50 millihenry, so we just get this output current waveform like this. So next, to find a harmonic spectrum of a VB, we just connected voltmeter at this RL load. So when we run this simulation, we just get the output like this. But we need to convert it to linear. With range from 0 to 2K. And then so we just get the harmonic spectrum like this of VB. So that's all from us. Thank you.